Hi everyone, I am Crystalline Gagliardi Gainsan for BID2. So here is my topic. So let's go.
Sound waves and its properties. Layers of the earth. Sound waves. Why does a tree make sounds when it crashes to the ground? How does the sounds reach people's ears if they happen to be in the forest? And in general, how do sounds get started and how do they travel? How sounds begin? All sounds begin with vibrating matter. It could be the ground vibrating when a tree comes crashing down, or it could be the guitar string vibrating when they are plucked. You can see a guitar string vibrating. The vibrating string repeatedly pushes against the air particles next to it. So the pressures of the vibrating string causes these air particles to vibrate, and then the air particles alternately push together and spread apart. Starts waves of vibrating that travel through the air in all directions away from the string. So the vibrations pass through the air as longitudinal waves, with individual air particles vibrating back and forth in the same directions that the waves travel. Sound waves travel through air in much the same way as water waves travel through water. So in fact, since water waves are easy to see and understand, they are often used as an analogy to illustrate how sound waves behave. Sound waves can travel through many different kinds of matter, so most of the sounds we hear travel through air, but sounds can also travel through liquids such as water and solids, such glass and metal. So if you swim underwater or even submerge your ears in bath water, any sounds you hear have traveled to your ears through water. You can tell that sounds travel through glass and other solids because you can hear loud outdoor sounds such as sirens through closed windows and doors. Speed of sounds. So the speed of sounds is the distance that sound waves travel in a given amount of time. You probably already know that sound travels more slowly than light. So that's why you usually see the flash of lightning before you hear the boom of thunder. However, the speed of sounds isn't constant. It varies depending on the medium of the sound waves. So generally, sound waves travel fastest through solids and slowest through gases. That's because the particles of solids are close together and can quickly pass energy of vibrations nearly particles. Sound is a form of energy produced by a vibrating bodies. Sound requires a material medium for its propagations, then sound does not propagate in vacuum as there is no material in a vacuum. So the to and fro or back and forth motions of an object is called vibrations. Some instruments produce sounds due to the vibrations of membranes, some due to the vibrations of strings, and some others produce pitch. The pitch of sounds depends on its frequency. So if frequency is more, then the pitch of a shrillness is more. The pitch of a woman's voice is more, and it is shriller than a man's voice. Examples of low-pitched sounds are animal roar, guitar sound, a large bell, and thunder. High pitch, nail scratching and blackbird, skull bell, the whistle, rubber shoes squeaking against a basketball court, then fireworks. Audible sound. Not all sounds produced by vibrating bodies is audible. The human ear can recognize sounds of frequencies in the range of 20 Hz to 20,000 Hz. This range of frequency sounds is called the audible sounds. Infrasonic sounds, it is the sounds of frequencies less than 20 Hz are called infrasonic sounds. Examples, humans cannot detect it. Sounds produced by earthquake, volcanic eruptions, and ocean waves, weather, waves, avalanche, waterfalls, meteors, lightning, and etc. Ultrasonic sounds, the sounds of frequencies greater than 20,000 Hz are called ultrasonic sounds. Examples, a dog whistle that cannot be heard by humans. An example of ultrasonic sounds is the detections of ships and objects underwater by bouncing a high-frequency sound wave off their hulls. Layers of the Earth. The structures of the Earth is divided into four major components, which is the crust, the mantle, the outer core, and the inner core. So each layer has a unique chemical composition, physical state, and can impact life on Earth's surface. Movement in the mantle causes variations in heat from the core, cause the plates to shift, which can cause earthquakes and volcanic eruptions. These natural hazards then change our landscape and in some cases threaten lives and property. Learn more about how the Earth is constructed with these classroom resources. Cross sections of Earth showing the following layers. Atmosphere. Earth's atmosphere has 5 major and several secondary layers, from lowest to highest. The major layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Continental crust. It is the outermost layers of Earth's lithosphere that makes up the planet's continents and continental shelves and is formed near subduction zones, plate boundaries between continental and oceanic tectonic plates. Oceanic crust is the uppermost layer of the oceanic portions of the tectonic plates. It is composed of the upper oceanic crust with below lavas and a dike complex and the lower oceanic crust, composed of trochlite, gabbro, and ultramafic cumulates. The crust overlies the solidified and uppermost layers of the mantle. Upper mantle. The upper mantle of Earth is a very thick layer of rock inside the planet, which begins just beneath the crust and ends at the top of the lower mantle at 670 kilometers. Temperatures range from approximately 200 degrees Celsius at the upper boundary with a crust of approximately 900 degrees Celsius at the boundary with the lower mantle. Crust. Earth crust is a thin shell on the outsides of Earth, accounting for less than 100% of Earth's volume. It is the top component of the lithosphere, a division of Earth's layers that includes the crust and the upper part of the mantle. It is the outermost layer of the Earth's surface. Mantle. Earth's mantle is a layer of silicate rock between the crust and the outer core. It has a mass of 4.01 times 1024 kg and thus makes up 67% of the mass of Earth. It has a thickness which is 2,900 kilometers, making up about 84% of Earth's volume. It is the layer that lies below the crust. Lithosphere. The lithosphere contains oceanic and continental crust that varies in age and thickness across locations and geologic time. The lithosphere is the coolest layer of the Earth in terms of temperature, with the heat from the lower layers generating the plate movements. Asthenosphere is the denser, weaker layer beneath the lithospheric mantle. It lies between about 100 kilometers (62 miles) and 410 kilometers (255 miles) beneath Earth's surface. So the temperature and pressures of the asthenosphere are so high that rock soften and partly melt, becoming semi-molten. Outer core. Earth's outer core is a fluid layer about 2,260 km thick, composed of mostly iron and nickel that lies above Earth's solid inner core and below its mantle. This will be the end of my topic. So thank you for watching and God bless us all.